In this video, I will explain how to use Kruskal's algorithm to find a minimum spanning tree in a graph. So let's start with a quick definition. A minimum spanning tree is a subset of edges in a connected weighted graph that connects all vertices with no cycles and has the minimum total edge weight. Now, to find this minimum spanning tree, we can use something known as Kruskal's algorithm, which uses the following three steps. Step 1 is select the edge with the smallest weight as the first edge in the minimum spanning tree. Step 2 is choose the next edge with the smallest weight. If it would form a cycle with the edges already selected, then don't choose it. If not, then add it to the minimum spanning tree. And step 3 is we just repeat step 2 until all of the vertices are connected. So let's jump into an example and see how we can actually use Kruskal's algorithm. So let's consider this graph right here. We want to find a minimum spanning tree in this graph. So we want to find a subset of edges that will connect all of the vertices in the graph, but we want to do it using the minimum possible weight. So step 1 of Kruskal's algorithm says select the edge with the smallest weight as the first edge. So we can see if we look at all of the weights of the edges in this tree, this one right here has a weight of 1. So this is the smallest weight. So this will be our first edge that we add to our minimum spanning tree. So let's go ahead and draw that over here. So here's our first edge in the minimum spanning tree. It connects vertex B with vertex D. Now, step 2 says choose the next edge with the smallest weight. So if we look at our graph here, we can see that the next edge with the smallest weight, there turns out to be two edges. This one right here and this one right here both have a weight of 4. So when you come across this scenario where there's two possible edges you can choose from, just choose either one, as long as it won't form a cycle with the existing edges. So we can see that neither of those would form a cycle with the existing edge. So let's go ahead and just pick this edge right here to add to the minimum spanning tree. So let's go ahead and draw that. Okay, so we've added this edge to our minimum spanning tree. Step 3 says just repeat step 2 until all vertices are connected. So we'll go back to step 2 and we'll choose the next edge with the smallest weight. So again, in this case, the next smallest weight would be this edge right here. So we'll add that to our tree. Okay, so we've just added that edge to our minimum spanning tree. Now we're just going to do that again. We're going to look for the next edge with the smallest weight. So the next smallest would be, we can see there's two edges right here that both have a weight of 6. Now what we'll notice about these edges is that if we chose to add either one of these to our minimum spanning tree, we would have a cycle, which we're not allowed to have. So for example, if we added this edge to the tree, here's what that would look like. We would have a clear cycle, which we're not allowed to have in a minimum spanning tree. And similarly, if we added this edge to our minimum spanning tree, it would look like this, where we would have a cycle right here with these three edges. So that's also not allowed. So even though these are the next two edges with the smallest weights, we're not allowed to add either of those to the minimum spanning tree. So that means we just move on to the next smallest ones. So the edges with the next smallest weight would be these two edges right here, which both have a weight of 7. And we'll notice that if we add either of these edges to the minimum spanning tree, it would not create a cycle. So it turns out we can add either one that we want to. So we'll go ahead and just choose this one to add to our tree. So once we add this new edge to the tree, we'll find that all of the vertices are now connected. So this is our final minimum spanning tree. So we'll go ahead and abbreviate that as MST. And we can find the total weight of the tree as well by just adding up the weights of all of the edges in the tree. And when we do that, we'll find that the total weight is 16. So that was just a quick example of how to use Kruskal's algorithm to find a minimum spanning tree.